Hello everyone. So I want to quickly go over data cleaning and attribute queries here in Python. So we're starting from our Google Colab notebook where we are going to install the appropriate packages. That's what we always start by doing. And then we're going to go ahead and import those packages separately. One thing I don't think I've ever pointed out is we import packages and install packages separately because we don't want to always install and then import. So if we install one time while we're in our working session, we can just come in and import those packages later on. So you can see that we do have some data sets that are required here for us, and if you look inside of Canvas, you'll see down here under week 3 resources and lectures that the week 3 data is here in a zip file, and you'll need to uncompress that zip file, and then you can simply click and drag that data in as I have already done over here. I have a couple of other files that I've been playing around with, but for the most part you just drag all of this data into your folder here in Google Colab. So we can go ahead and import that data and we get a printout. Now the first thing that we really need to do here with this practice workbook is we need to combine world population to our world country shapefile data set. So we just read in our shapefile using gpd.read file, and the next thing we want to do is read in our world population. And so now you can see that we have our world population from 1960 to 2024 per country in the world. So the next thing we want to do after we've done that is we can start cleaning up and maybe just keep 1 year of data. So we don't really need every single year unless we're doing some more in-depth studies of world population, or maybe looking at a population for a specific country from 1960 to present. Specifically, I'm just going to pull 2022 out for now, and you can see that I now have that. And the next thing I want to do is check matching columns. So before I merge my shapefile with the World Bank population data, I want to see if there are any column names that are similar. So we have name and ADM 0_83, which is a 3-letter ISO code, which will match our country to our ISO code. So we have our country name and then the ISO code name. And then we can join on that. So now we see we have Indonesia with its population, Malaysia, Chile, Bolivia, Peru with their populations associated with it. So to do that merge, we simply just use a GeoPandas function, world.merge. And so we say we want the clean population that we had queried on, and that's up here where we take pop clean.dropNA. So when we say drop NA, we're just dropping any missing values within our data set. And remember, we can see our data set up here when we look at it. This is also a CSV file, so you can open the data set in a spreadsheet and view it that way as well if it helps you to kind of build a mental image of the data. This is what it looks like when we open a spreadsheet, and it's not that much clearer. We do have the years up here, we have the country names over here, but there's a lot of stuff that we just don't really understand. There are no missing values in here, or there shouldn't be. This is a pretty complete data set from the World Bank. So if we scroll all the way over, there really shouldn't be any missing values, but this is dropping the NAs is something that you want to do in practice, because if there are missing data or there are values inputted for missing data such as -9999 or 0 when it's not really 0, it can skew your statistical results when you are dabbling with that later on in the course. So now that we've merged our data set, our shapefile and our population data set, one of the things that we need to take notice of is that we've now created a geodata frame. So it's still a shapefile, but it's more of a geodata frame while we're working in Python. So when we've printed this out, a lot of that data is still available to us, but it's just a different data format. We can write it back into a shapefile if we use worldpop.write2, and we can save that out and export it as a shapefile that has the combined countries and population together. And in fact, at the end of this, after working through all of this notebook, I do recommend that you export that shapefile just to have it for future labs, so you're not always having to merge it yourself. So for data cleaning, there's often a couple things we want to do. Check for missing values, drop duplicates, fill missing population values. And again, we can fill it with 0, or we can use the median value depending on what we're doing. 0 could work well. If we're doing some type of statistical analysis, which we will do later on in the course, we really want to make sure that we are filling that with a value that makes sense. So the median would kind of be better, but that's also somewhat erroneous to use in this situation, just because it wouldn't be a true representative data point of population for that country in that case. Standardized country names with the title case. So this way, instead of having the ISO code, we have the actual name of the country. Make sure the ISO codes are uppercase, so that way they're not lowercase and we're not confusing them with other names. And then we can just print all this out. And you can see that whenever we subset, we're doing a couple things. We're either calling a subset directly. So this is a GeoPandas function. And we say subset based on name and the ISO code. When we want to fill values, we're calling a particular column. So in this case, we're saying worldpop. And then within our worldpop data frame, if I hover over this, you see it's a geo data frame. So that means within our geo data frame, we have a column that's called population 2022. And we can verify this. If I get in here, let's come down here and add a code cell. You can verify this by typing worldpop.head. And you can see up here we have a bunch of different column names. Pop 2022. So we do have a column name Pop 2022 that also shows up in our data frame that we can see. And so I'll go ahead and delete this. And we just want to fill anything that is empty with 0 if there's something that's with 0. So I'll go ahead and reprint this back out so we can see the results. So there's nothing that is empty, so there's no need to fill anything with 0. We're going to standardize the names to make them all title case, which we've done. And this is just showing us that all the values have been cleared, so there's nothing missing. We did modify the country name and country codes, but that's it. Okay, the next thing we're going to do is we're going to start doing attribute queries. So we're going to select countries by attributes. So specifically, we're looking for countries that have a population of 100 million or greater. And so again, we are, in this case, you might recall that we subsetted on the column. So here we're saying world population for the year of 2022. That's our column with our population data in it. So what are we doing here, since we have this kind of on top of our column selection? Well, we're saying that we want to basically select all of the data. So this world pop with pop 2022 is specifically highlighting the column population 2022. When we wrap that on another level, so we're saying world pop here, select world pop 2022 that is greater than 100 million. We're saying take all of the other data that is within our world pop data frame that is related to 100 million and store it in the variable large pop. So now we can just select large pop population 2022 that has a population greater than 100 million. So in large pop, it's only the countries that have a population greater than 100 million. And then what are we doing here? We say dot apply lambda x. Lambdas are essentially temporary functions. So dot apply is how we apply a temporary function. So we're saying the lambda x is a function of int x. So this is essentially just formatting. So we're saying look specifically at the values and format them with commas. So we're saying take the number and format it with a comma. Again, this is something you could play around with. This is purely for formatting itself. It's not something that's absolutely required. But all we've done is use a lambda function to apply a comma in between the values. So that way it's not written where the values are like 2.73e plus 0.6. And if you want to see what that looks like when we print it out, these numbers are easily legible. 278,830,529. If I comment this out, you see we get 2.788305e plus 0.8, which means there are 8 trailing zeros behind that number. So this would be 8 trailing zeros, or 8 zeros in total. So this would essentially be 278 million for world population. And that's kind of hard to interpret for somebody who's looking at the data. So it's good to go ahead and just format that so that way we can see exactly what that number is without having to do that conversion in our head on the fly. Keep it simple, and everything else you do will be relatively simple as well. Now for spatial queries, what we want to do is filter features using spatial operations. So let's say we want to make a geodata frame for South America only. Well, once again, we want all of the data for any continent, any country that is within the continent of South America. So that's all we're doing there. That's another subsetting query right there. And then we're going to define a bounding box. And specifically, we're making a rough box around the country of Brazil. So we have our minimum x value, which is our x would be our longitude, and y is our latitude. So we have longitude, latitude, longitude, latitude. And what we are doing here is basically saying this is a query box. We're setting our coordinate reference system for that query box, and we're setting up a box that we can apply over the data in order to select certain information. So now if we print it out, it'll print out the countries inside of our bounding box. And we see that we get Chile, Bolivia, Peru, Argentina, Suriname, Guyana, Brazil, Uruguay, Ecuador, Colombia, Paraguay, Brazilian island, Venezuela. And these are all countries that come into play because we made a bounding box around the area. Okay. So the next thing we can do is automate the query, and for automating anything, it's always going to be a function. Whenever you hear somebody say they're automating something, it's essentially a function that has all of these little, subset queries that we have written previously in examples, and they're just stuffed or nested, which would be the more proper term, inside of a function. So here we're saying query countries, and we want minimum pop, maximum pop, continent, and we're looking for specific parameters. So in this example, we're gonna provide a minimum population value, a maximum population value, or we could provide a continent. And so once we run this, essentially what we're going to be looking for in our example down here is our world population. From our world population geodata frame, we want all countries within Africa that have a population greater than 50 million. So we run this, and we see that we get another geodata frame that has all of the countries in Africa with a population greater than 50 million. And then we can visualize. Now, There is some confusion here with the visualization, and that's because I have an activity here for you yourself, where when we plot this, we're going to get all of the world countries, but these are world countries that have a population greater than 100 million. And so what I want you to do is I want you to test around with plotting Africa's population. And I also want you to test around with plotting some other countries. Play around with this query. Yes, I say try plotting Africa's population, but mess around with it. Try to plot countries that have less than 50 million, or plot countries that are between a certain range of values. You can also do other features like country area and size if that data is available within the shapefile. But really just try to get creative with how you query this data and make some of these maps. And that will help you kind of wrap your mind around understanding how to perform these queries and select data from within the data set itself. All right, that'll do it for this time.